Okay, so good morning, everybody. Today we are going to learn how to be a .NET debugging Jedis. So, there are two types of developers. There's the developers that don't want to think. They press F10, 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 sometimes even maybe F11, and they hope that they will get lucky and maybe see something unusual happening in front of them and find the bug this way. Though these developers are not usually productive because they are not utilizing the tools that are provided for them in order to find the bug faster. So what is the second type? Well, the second type is the type that's always in command, always in control. And these types are really productive because, first of all, they always utilize the tools that are provided for them, but most importantly, they are always one step ahead. So before they will jump in, they will think about a hypothesis, and then they will carry on to test this hypothesis, and according to the result, they will decide how to continue. But before that, I will introduce myself briefly. My name is Moaid. I am a software engineer, consultant, and a code Jedi. And I'm going to talk about how we can be more like that guy. And please excuse the irony, so I'm talking about Jedis, and this is Dark Vader, which is Sith Lord, so that's okay. And I accept and love everybody, even if you are a Sith Lord, so it's okay. I work in CodeValue, which is a consultancy in Israel. And this is the agenda. We'll talk about the different types of breakpoints. We'll talk about the disturbance in the force, which is bugs. We'll talk about how can we debug unowned code, which is, for example, third-party libraries that we don't currently own the code for it right now. Maybe we don't have the source code. We're going to talk about debugging attributes, debugging in multi-threaded code, and finally, sysinternals. Okay. So before we start, why debugging? We'll take a minute and read the tweet, which is actually correct if you think about it. Thank you. And this moth was actually the reason for this unexpected behavior. Well, this is the first bug report. And this is the famous moth that started the use of the term bug in software engineering. But we have two issues. First of all, this wasn't a software bug, but a hardware bug. And secondly, it wasn't the first time that this term was used. So it was used before there. Thomas Edison actually, in a letter that he wrote to his associate, used this term. And he said that during the development phases of products, some difficulties may arise, and he called these difficulties bugs. Okay, but that wasn't important. What is important is to note that every minute we spend debugging is a minute we're actually losing. Because when we debug, we don't write code. When we don't write code, we don't add new features. When we don't add new features, we are not providing new value. More than that, if you're debugging, we're actually saying that we have delivered less value before than we thought. And in order to be more productive, we need to make the what the heck to the aha moment time really minimal. And I'm going to talk in this session about ways, steps, or tools that we can utilize in order to minimize the debug time. Take a minute and read this tweet. which is also true. Okay, so how do we minimize debugging time? Well, there's a few ways that we can do it. First of all, me personally, whenever there's something that I don't fully understand, I just go to my teammate and I try to explain it to him. And more often than not, I will find that only by explaining this to him, I took a better control, I gained a better control of the things that I'm explaining to him. But let's get real, Moaid, okay? We are software engineers, and we write a lot of code alone, maybe at night at home. And there's not always somebody around that we can go and try to talk to him. So instead of talking to the walls, let's choose an object that we can pretend that this object is a person, and we can try and explain this stuff to this object. Well, somebody has chosen a rubber duck. And it's called rubber ducking or rubber duck debugging, but we are trying to be a .NET debugging Jedi, so normal rubber duck won't do. We need a Star Wars rubber duck. Okay, so we did that, okay? We talked, and still didn't work. There's something that we are not fully understand yet. So what we will do, well, first of all, we are craftsmen and craftswomen, and as any other craftsman, we have tools. So for example, if a carpenter has a saw and a hammer, what do we have? An IDE and a debugger. And we need to learn how to utilize these tools in order to minimize this debugging time, or the time to the aha moment. Though we are trying to become a .NET debugging Jedi, so these tools won't do, we need lightsabers. Okay, so about the tools, when there's something that we need to investigate, what is the first thing that we do? Well, we'll go there and we'll place a breakpoint. But a normal breakpoint maybe will be sufficient for most of the cases, but it won't always. For example, maybe we have a list, a collection of some items, and a loop, and we notice that only at the 20th iteration, something starting to happen, something weird. So instead of pressing F9 or adding a normal breakpoint at the margin of the IDE, what we can do, and start pressing F5, 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 F5 20 times, what we can do, we can use something called conditional breakpoint. And we have a few types of them. So the first type, called conditional expression. Well, we can write expression that exactly like in an if clause, and every time the program will reach in execution the point where a breakpoint is placed, the expression will be evaluated, and if it will yield true, then the breakpoint will stop the execution of the program. And we will see an example. We have some few modes, but in addition, we also have a hit count. So if we know that in the ith iteration we need to stop the program, then we can place a breakpoint, and in the hit count we can place the index. So it's really important to remember that this index isn't zero based. So we'll have to start from 1, 2, 3, 4, not 0, 1, 2, 3. So what is the next type? Well, it's filters. So we can filter when to stop the program according to some variables. For example, the current thread ID, thread name, process name, machine name, okay? So when this is useful, for example, if we have a method that is being executed by different threads, and this method has multiple breakpoints, and we need to jump from one breakpoint to another, and we need to make sure that the jump from one to another breakpoint will stay in the same thread. So this is one way, so we can filter according to the thread ID or thread name, and this is one way to do it. Okay, so let's look on the demo. Okay. Okay. So for example, here I have a list of Jedis and a list of Sith Lords, and I combine between the two in one list, and just run a really long loop in which I will train them. The train currently don't do anything, but maybe maybe there's something strange happening in the ith iteration. So what can I do? I can place a breakpoint, right-click it, and then go to conditions. And then I can choose whether to write expressions. For example, I know that Force users have midichlorians, which is how much they're strong with the Force. So for example, I want to break when I reach a Force user with a midichlorian level that is smaller than 6,000. So what I can write here in conditions, I can write user dot midichlorian. I also have IntelliSense, by the way, smaller than 6,000. Okay, and when I will run this program currently, it will break, and I can see that we stopped on Obi-Wan Kenobi, which is okay. So it also has from under 6,000, but let's say that I want under 3,000. So can just edit it. Second. Sorry. I can go here and write under 5,000. Okay. And now when I will run it, we can see that it's skipped. We can see that it's a Mace window, and it skipped Yoda, Obi-Wan Kenobi, Luke Skywalker, and start when we reach this one. And we also can do the same with hit count. So if I will press a breakpoint, second, okay, a condition, hit count, and can press 4, and we will reach the same conclusion. We'll stop at the same place. Okay, so this is cool, but we have more options. Okay, so what do we have? Well, we have actions. So let's assume that we have some programs that is really sensitive time-wise. So maybe you are sending or handling remote calls, or I don't know, browser request, and if I will place a breakpoint, then I will start on getting timeouts. Or maybe I have a list of items, and what I want to do is instead of and I want to know specific information about each item, but instead of stopping the execution each time to examine the state myself, I want to generate a report. So I can use an action, and an action or a trace point will give me an ability to use to write string that's really similar to the string interpolation in C#6 in order to generate messages like in the output window for each item. So for example, in this example, I have a Force user, and I'm just printing some information regarding a Force user. But we have something that is even cooler than that. We can also use some special variables, some like a call stack function, and so we can determine where and when did we reach, from where did we reach this code, this breakpoint. But what's cooler is the method breakpoint. So what we can do with the method breakpoint is we can add a breakpoint by method name. And we can either specify the class name, so it will place a breakpoint only at method in the class name, or we can leave the class name and it will place a breakpoint on every method with the same name, even if this is not our code. And I will just show you an example of that. More than that, it can place a breakpoint on methods in an assemblies or modules that are not currently loaded. But when it's useful, well, for example, maybe I want to place a breakpoint really quick, but I don't want to find the class for that. Or, as I previously said, for a class that is in a third-party library. So what can I do? Well, let's try it. Okay, just a second. Okay, so I have here the same list of Jedis and Sith Lords, but in the train method, I'm using a third-party library, and I'm using a class called Star Wars Academy to train each Force user. Okay, and I know that each Force user will eventually reach a method called useForce. So I can just press Control B and write the method useForce. Okay. So after placing it, I can see that it's already defined in the breakpoints window, which is actually really useful because in the breakpoints window, I can see all of the breakpoints. I can disable some of them if I want to, or delete them. So if you need to remove a lot of breakpoints at once, or see where's all of the breakpoints, this is one way to do it. And now, if I run the program, I can see that it stopped here. But let's look on the call stack. Well, I want to know who called me, but I see here external code. Why do I see it? Because this code is not mine. This is a code from a third-party library. So how can I determine what is this code? What is this code? Well, I can do it in 2 steps. First of all, I can go to Tools, Options, and then I can disable just my code. So if I will run it now, I can see the full stack. So there's a method here called training schedule. And if I try to press on it, well, I can't load it because I don't have the source code for it. So what can I do? Well, debuggers can show us the source code according to a symbols, and usually the symbols are in a PDB file. So I know that there's a session today about PDB, so I won't talk about it much. But what we can do is that we can use a decompiler to decompile an assembly, a C# or .NET assembly to C#, or at least to extract the symbols for the assembly, and then we can use the symbols to view the source code. So how we can do it? Well, we can use JetBrains .peek. This is actually a free tool, and I can go to Tools, Options. Before that, we should start the symbol server. Okay, I will go to Tools, Options, and I can define it however I want, and it will generate a URL. So I can copy it. Okay, and when I'll go here, I can just add new path, paste it, check it, and now I can press load, and it showed me the source code of the third-party library. More than that, I can even debug it. So, for example, we have here the training schedule method. If I want to break on it, I can just Control V. I can press F5, and it will break when we reach that method. Okay, so what else can we do? Just a second. Okay. So what are the drawbacks of the breakpoint that we already saw? Well, it's actually performance, because each time when we reach a breakpoint, even if it's a conditional breakpoint, what we will do is that the debugger will stop the execution of the program, then we'll evaluate the breakpoint, the condition, and according to that can decide whether to continue with the execution or to stop it for the breakpoint. And this is actually the graph for it. So there's a loop, wait for debug event, where a debug event is actually a breakpoint. When a breakpoint will be hit, it will handle the debug event. Currently the program is stopped from running. By handling it, if it's a conditional breakpoint, it will try to evaluate the expression, and then it can decide whether to continue or not. So how can we solve it? Well, one example is for using debugger.break. So we can add a breakpoint, or we can, if we have a debugger attached to the process, we can ask the debugger to stop the execution and to go to breakpoint mode if you use this method. But maybe I am at debug, but I don't want every time to stop at this breakpoint. Well, what I can do, I can define something called conditional compilation symbols, which is actually just a name for a symbol that we can define at compile time. And what it do is that we can add if and end if directives. So what it will do, when the compiler reaches this code, it will check if dark side is defined. It will, if it isn't defined, it will skip the code. It won't compile the code between the if and the end if. So if I'm at debug and I don't want to stop at this breakpoint, I can just not define dark side, and it won't stop here. But using if and end if isn't really nice to see when you're looking on code, and if you have a multiple debugger.break method in one method, it will be cumbersome. So what we can do, we can use a conditional attribute that will do the same thing, but by the compiler automatically for us. So it looks a little bit better. And it's actually used in the debug.writeLine and trace.writeLine in Microsoft Code. This is actually from reference source. Okay, but something even cooler was an object ID. So let's say that we currently in some class, in some method, and there's some object that we want to monitor its behavior and its state. But we want to do that later on when the object is out of scope, when we don't have a reference to this object. So what we can do, we can generate an ID for this object, and then we can reference this ID either by the watch window, the immediate window, or even in the conditional breakpoint. So let's see how we can do it. Okay, so let me go here. We can even do it here. Okay. So I have the list. I can stop here. I want to view all of my objects in the list. So maybe I've decided to monitor Darth Vader. So I can press it, make an object ID. We can see that it got the ID 1, so it's a $sign and then the number of the ID. I can evaluate it in the local window, but if I'll go to the breakpoints, I will delete them for the moment, and I will create a new one, okay, that will also stop in use force. But this time, I want to make it a conditional breakpoint, and I want to stop it only if only if the current instance is Darth Vader. So how can I do it? I can just write object dot reference equals and I can send it this and $1. Okay, so if I will run it now, if I continue running, let's see what will happen. Okay, so we can see that the breakpoint skipped all of the rest of the items and only stopped the execution of when we reach Darth Vader. So this is cool. Okay. What else? Well, we can use the Lambda starting from Visual Studio 2015. We can write Lambda expressions and link queries inside the immediate window and inside the watch window. So we need to be careful because there's a Heisenberg bug. What is a Heisenberg bug? Well, it is a bug that will alter or change its behavior when we'll try to view it. And this is not Heisenberg. We're not talking about Heisenberg. We're actually talking about Star Wars Heisenberg. So Heisenberg was actually the researcher, the scientist that firstly used this term. Not Heisenberg, but the term that when we view something, we might alter its behavior. So how can we solve this? Well, for example, if we are looking in the watch window on some property that every time it will be evaluated, it will be changed, we can add NSE, which is no side effect, and each time, and it will run it in some sort of a sandbox, so it won't change the actual value. For example, if we go to the code, okay, please also don't do it at home. Don't make properties that by accessing the getter, it will change the state. Don't do it. But for this session's sake, I will place here a breakpoint. I run the program. In the watch window, I'll add counter. Okay, and so now we can see that each time I'm breaking here, the value of the counter changes only by adding counter to the watch window. So if I'll just add NC, which is no side effect, from now on, when I'm pressing F5, it won't change. Okay, and I finished the program. Okay, but it stayed 4. Okay, but let's look on debugging attributes. Well, let's look at this screenshot. We have a list and we're trying to view the list, but what we are seeing in each one is it's either the default to string or our definition of to string. But it's not optimal. Maybe I don't want to change my toString just for debugging purposes, or even maybe I can't. Maybe this is not my code. Maybe this type that I'm trying to view here is actually part of some library that I don't own. So I actually can't change it from this to this, but I can specify what is the information that I want to see. How can I do that? I can use an attribute called debugger display attribute, and in the attribute I can write an expression in a string that's similar to the interpolation of a string interpolation, and I actually can ask the debugger to show me the information that I want. I can either place the attribute above a method or in the assembly level. Sorry, or in the assembly level for cases that we don't own this code. I will show you in a moment. But let's look on another issue. Well, so I have the display attribute, but when I try to view the properties of each item, I see these properties. And well, maybe I have a lot more that are not relevant for me, or maybe I need properties that will return more information that are useful for this debugging session. But again, either I don't want to add properties to the type just for debugging, or I can't. What can I do? I can transfer that code to this code by adding a type proxy attribute. And the type proxy, what it will do, it's a new type that can expose only the information that I want. And this type is usually an inner class of the contained type, so it can access private members. How does it look? Well, this is an example of the type that we are seeing here. Okay, so it must accept in the constructor the object of which it wants to display, and then can expose the types, the properties, sorry. But this is not enough. So I have this view now, and it's okay, but I have the abilities array that I need to expand each time I want to see what are the values of it. So what can I do? Well, I can add a browsable attribute, and I can specify no root, so I can see all of the values of the array without pressing on the expand, little plus and expand button. Exactly like that. Okay, this is the full code, so it's the same type proxy class, but I just added an attribute over the property that returns an array, or a collection, enumerable. And okay, but this is cool. What else can we do? So I have this list, I have these items, but this is not enough because maybe I need a better way to view these items. What can I do? Well, I can use debugger visualizers. So I just remove this breakpoint. I will go here. And I place a breakpoint. And now each time I try to access an item, I can press on this symbol and give it a second. Voila. I can see a visualizer, another class that can help me see better the items that I want to view. For example, I can do it also for all of them. For example, if it's a Darth Vader, then I can see a picture of Darth Vader, and it also works for lightsabers, but we don't have time. And I've added it by using another assembly with a new class visualizers, and just opened a new WPF window, and the WPF window will use according to the items will show me a picture. Okay, and I can set it, and I can set this. I can map between the two types according to the debugger visualizer attribute. Okay. Sorry. Okay, but we can use it for better purposes. So if we have an array of numbers that represents a graph, we can actually show a window of a graph that is also interactive. Or even if we have a complex linked list with circular dependencies, we can actually visualize it this way. Okay, so what about, this is cool, but what about multi-threading? Well, there's a famous threads window where we can view all of the threads, view all of the call stacks of the threads. We can rename them, freeze them, resume them. But it don't give us, like, it's useful, but sometimes we need to get more context. So, okay, so we have the task window that it's similar, but we can see the details of the tasks, and sometimes it can also determine whether there's a deadlock or not, according to how complex the deadlock is. But most importantly, we have the parallel stacks window, which shows us the stacks and how we got to the current point in the execution, to threads or to tasks. And it's really cool because when we change a frame, when we choose a thread, we can see the path of the thread. So for example, in this picture, we can see that on the left one, we can see that we started from 4 threads. Then 2 of them went to run the method I in a class named S, then the method J in a class name in the same class. But then one of them went on and ran a code that we don't own, and another one ran a method K, then L, then O, then P, then Q. Okay, so it can be really useful. We also have the parallel watch window, which we can view if we have a method with arguments or with variables, and we have multiple threads running this method, where we can view all of the variables for all of the threads at once, which can give us better context. And what's cool is that it can also work in recursion. Okay, so we don't have time, sorry about that, we don't have time to talk about these internals, but they are tools maintained by Microsoft. We can find them at this site, live.sysinternals.com, or by shared folder if you want to copy all of them at once. And one of the tools that I like to use is Process Explorer. And it's really like the task manager, but it gives us more abilities. For example, let's do it really quick. If I run it now, and I run, for example, my program at a breakpoint, okay, I can go to the Process Explorer. I will try to search for my program, which is called The Return of the Jedi. Okay, I can see already all of the assemblies that are loaded, but if I double click on it, I can see more details. For example, I can see all of the strings that I have defined. I can see all of the .NET assemblies that is currently loaded, grouped by app domain. And if there's a DLL that I can delete, for example, because some process is using it, what I can do, I can press Control F, and I can search for it, okay? Okay, just a minute. Sorry about that. Okay. So first of all, now you are a Jedi apprentice. In order to continue, you should learn about WinDBG, but we can do a lot of sessions about WinDBG. So we talked about minimizing the time to the aha moment. We talked about breakpoints, debugging unowned code, about debugger attributes, and briefly about multi-threaded code and its internals. So, but remember that debugging is really hard. Even master Jedis sometimes be baffled by it. So we need to practice and always to try to reach the I'm in control guy, or Darth Vader, but stay on the Jedi side. Okay. So you can find the code in this GitHub link, and I will post the PowerPoint to the slide shared later. Okay, so this is the end of the presentation, and currently we have 5 minutes of Q&A, but be aware that there are a prize for the best question. So do your best. Thank you.
Hello, thank you for the presentation. I have a question about your the most hardest experience in debugging. For example, my experience, I have very big problems with debugging VPF application written by the students. And another one is...
Sorry, can you just repeat the last sentence?
I just want to ask you about the most hardest experience in debugging.
Okay.
That you met. For example, the most hardest experience was the debugging the VPF application written by students. And another one is remote debugging of .NET Server, which use C++ CLR components.
Okay, so this is working?
So what's about
Okay.
you? What was
Okay,
the
so
hardest experience?
my hardest experience, I think, I was working with a client that has a machine that's some sort of robot in a factory. And it has a lot of legacy code that's written really long time away, and it also was a remote, so we had to remote debug this machine. And the thing is, some of our tools that I use don't work in remote debugging. Not the tools that I showed you here, but other tools. And what we had to do is just we had to go to the factory that is in a remote site, sit and work with a really small screen and try to figure out what's happening. And for example, in that site, I had to use the parallel debug window, so I can take better context of what's happening. But I agree with you that it's easier code that was written by inexperienced programmers or a really old code.
So it was just like debugging the black box.
Yeah, some sort of.
Because lots of stuff you don't have access to.
Yes.
Okay, thank you.
My pleasure.
Hello, thank
Hello.
you for your good talk. What do you think about new UI for WinDBG?
About what?
New UX for WinDBG.
Okay, I saw it. I didn't have a chance to try it yet. I liked how did they use the ribbons and then everything, but I just didn't have a chance to use it. So, sorry.
Hello, thank you for presentation. My question is that everyone in this room, I guess, experienced this evaluation timeout. Is there any hack to avoid it?
Evaluation timeout?
Yeah, when you're in debug mode and you would like to get some value, you run some function, and this is an evaluation timeout. It usually happens, I don't know, like for external DLLs.
Okay.
And is there any way to avoid it?
Are you talking about when by stopping the execution of the program will actually cause a timeout? Okay, so for example, I've talked about the trace points and about actions. So when using trace points or actions, I can get information about the state, about the current state, without halting the programs for a long time. So it should prevent actually timeouts like that, if I understood the questions correctly.
Okay, our last question.
Hello, thank you for presentation. I have a question about new features in Visual Studio. These are code map and IntelliTrace. Do you consider these features as useful for our work, and how often do you use them in your daily work?
Okay, so code map can be really cool, but it depends on how complex your project is. This is not fully about debugging, but about understanding the project. I actually don't use it a lot. I use other products. They cost money, so I won't talk about them here. I don't know if I can advertise them. I can tell you afterwards if you want. And the same about IntelliTrace. So IntelliTrace is actually cool. I like it. Okay.
Okay, who was? You can catch Moaid in the lobby, I think. And
Yes.
who was the best?
I'm guessing the first question with the guy that's sitting there.
Okay. Okay, we'll give you the present later. Thank you very much, Moaid.
My pleasure.
Now we have a break, and the next topic will be at 12 in 20 minutes.